Substantially better. So basically, in a solid state battery, we have replaced that volatile and flammable liquid and gel polymer electrolyte.
The automotive industry is on the edge of a major transformation, with electric vehicles leading the way in reshaping how we think about transportation. Hyundai is one of the leading brands to birth the dream battery, the solid-state battery that will shock the entire EV industry. What Hyundai will introduce changes the game. Hyundai's key features on its solid-state battery innovation. Amidst this change, battery technology remains a critical area of innovation. Hyundai, one of the world's largest and most influential automobile manufacturers, is setting its sights on revolutionizing the EV sector with its new solid-state EV Dream battery. This game-changing battery promises to enhance the performance, efficiency, and safety of electric vehicles, addressing some of the long-standing limitations of current lithium-ion batteries. As the world moves towards a greener and more sustainable future, Hyundai's breakthrough has the potential to propel the EV market into a new era. The world is at a crossroads in the pursuit of sustainable energy solutions. As the demand for cleaner and more efficient energy storage technologies rises, one innovation stands out as a potential game-changer: the solid-state battery. As electric vehicles, EVs, renewable energy systems, and various electronic devices continue to push the limits of energy storage, the need for advanced, safer, and more efficient battery technologies is critical. Solid-state batteries promise to address many of the shortcomings associated with conventional lithium-ion batteries, which have long been the dominant energy storage technology. Hyundai's solid-state EV Dream battery incorporates several advanced features that make it stand out from current EV battery technologies. One of the most notable improvements is its energy density. Solid-state batteries can store more energy in the same amount of space compared to lithium-ion batteries, which translates to a longer driving range for electric vehicles. This is a key concern for many consumers, as range anxiety remains one of the most significant barriers to widespread EV adoption. Hyundai's solid-state battery could potentially increase the driving range of EVs by up to 50%, allowing electric vehicles to travel further on a single charge. Another standout feature of the solid-state EV Dream battery is its faster charging capabilities. Solid-state batteries can charge more quickly than lithium-ion batteries, significantly reducing the amount of time it takes to recharge an electric vehicle. For consumers, this translates to greater convenience, as they will spend less time waiting at charging stations and more time on the road. The ability to fully charge an EV in a matter of minutes, rather than hours, could greatly enhance the appeal of electric vehicles, making them more comparable to traditional gasoline-powered cars in terms of convenience. Safety is another critical area where Hyundai's solid-state EV Dream battery excels. Traditional lithium-ion batteries are prone to overheating and, in some cases, catching fire due to thermal runaway, a process where a rise in temperature causes a chain reaction that can lead to a battery failure. Solid-state batteries, however, are inherently safer because they eliminate the flammable liquid electrolyte, replacing it with a non-flammable solid electrolyte. This significantly reduces the risk of fires or explosions, making electric vehicles safer for consumers and reducing the potential for costly recalls or safety incidents. Additionally, solid-state batteries have a longer lifespan compared to traditional lithium-ion batteries. The solid electrolyte is less likely to degrade over time, which means that the battery will maintain its performance for more charge and discharge cycles. This characteristic makes solid-state batteries ideal for long-term use, potentially reducing the frequency of battery replacements and lowering overall maintenance costs. What is a solid-state battery, anyway? At its core, a solid-state battery is a type of battery that replaces the liquid or gel-like electrolyte used in traditional lithium-ion batteries with a solid electrolyte. This seemingly simple modification has profound implications for performance, safety, and overall efficiency. Like conventional batteries, solid-state batteries consist of three main components: the anode, negative electrode, the cathode, positive electrode, and the electrolyte. However, in solid-state batteries, the electrolyte is a solid material that conducts ions, charged particles, between the anode and cathode during charging and discharging. Solid-state batteries have the potential to significantly improve upon the limitations of liquid-based electrolytes, which are prone to leakage, degradation, and safety hazards such as fires and explosions. By using a solid electrolyte, these batteries can operate at higher energy densities, charge faster, and be safer than their liquid counterparts. While the technology is still in development, many believe that solid-state batteries could revolutionize a wide range of industries, from consumer electronics to electric vehicles, by providing more power and efficiency in a smaller and safer package. The basic working principle of solid-state batteries is similar to that of conventional lithium-ion batteries, but with key differences in the electrolyte. In a lithium-ion battery, the electrolyte is typically a liquid or gel composed of lithium salts dissolved in an organic solvent. During discharge, lithium ions flow from the anode to the cathode through the electrolyte, releasing energy in the process. Conversely, during charging, lithium ions travel back from the cathode to the anode, storing energy. In a solid-state battery, the liquid electrolyte is replaced with a solid material that serves the same purpose, allowing lithium ions to flow between the anode and cathode. The solid electrolyte is typically made of ceramics, glass, or polymers, all of which have the potential to offer high ionic conductivity. The solid-state design eliminates many of the safety risks associated with liquid electrolytes, such as leakage and flammability, while also allowing for more compact and efficient designs. Additionally, solid-state batteries can operate with higher voltage and energy density, resulting in longer-lasting and faster charging devices. Evolution of battery technology. The history of battery technology is a story of continuous innovation, fueled by the need for portable, reliable, and efficient energy storage systems. From the earliest attempts to store energy chemically to the sophisticated, high-capacity batteries used in modern electric vehicles and smartphones, battery technology has evolved dramatically over the centuries. As the world increasingly turns to renewable energy sources, electric vehicles, and other high-tech applications, understanding the evolution of battery technology provides insight into how we arrived at today's energy storage solutions and offers a glimpse of the future. The story of batteries begins in the 18th century with the discovery of electrochemical reactions. The first true battery, the voltaic pile, was invented by Italian scientist Alessandro Volta in 1800. Volta's invention was composed of alternating discs of copper and zinc, stacked on top of each other and separated by layers of cloth soaked in salt water. This stack created an electrical current, marking the first instance of practical electricity storage. Volta's discovery was revolutionary, and his pile became the foundation for further advances in electricity generation and storage. While Volta's pile wasn't practical for long-term use, it opened the door for the development of early battery technology. In the decades that followed, scientists like Humphrey Davy and John Frederick Daniell built on Volta's work, creating better and more stable batteries. The Daniell cell, invented in 1836, used copper and zinc electrodes and a sulfuric acid electrolyte, which provided a more reliable and consistent current. These early batteries were primarily used in scientific experiments and were not yet practical for mass consumer use. As the 19th century progressed, battery technology continued to evolve, primarily driven by the Industrial Revolution and the burgeoning demand for portable power. In 1866, the French engineer Georges Leclanché developed the first dry cell battery, which was a significant improvement over earlier wet cell designs. The Leclanché cell used a paste instead of liquid electrolyte, making it more compact and practical for consumer use. This battery was the precursor to the common dry cell batteries still used in flashlights, remote controls, and many other devices today. By the late 19th century, the development of the lead-acid battery by the French engineer Gaston Planté in 1859 had a major impact on the world. Lead-acid batteries became the standard for automobile power systems, providing a reliable and rechargeable source of energy for early vehicles. The lead-acid battery was durable, could be recharged, and had relatively high energy density, making it ideal for transportation applications. This innovation marked the first time batteries were used for practical, everyday devices and signaled the beginning of the transition from static electrical experiments to portable energy storage. Of course, who would forget the alkaline battery era? The early 20th century saw gradual improvements in battery technology, but it was not until the 50s and 60s that real advancements were made. Alkaline batteries, which replaced the zinc-carbon battery, became the standard for consumer electronics. Invented by Canadian chemist Louis Urey in 1955, alkaline batteries offered significantly higher energy density, longer shelf life, and better performance in a variety of devices, including flashlights, radios, and cameras. These batteries have remained popular for low-power, everyday applications due to their reliability and efficiency. However, as electronics became more powerful, the limitations of traditional alkaline batteries became apparent. To power more energy-intensive devices like portable computers, medical equipment, and the growing array of personal electronics, a new type of battery was needed. In 1980, a major breakthrough occurred with the development of the lithium-ion (Li-ion) battery by researchers John Goodenough, Akira Yoshino, and others. The lithium-ion battery was a game-changer, offering a higher energy density, lighter weight, and better efficiency than previous technologies. Lithium-ion revolution, rise of portable power. The commercialization of lithium-ion batteries in the 90s heralded a new era in portable electronics. These batteries could store more energy in a smaller, lighter package, making them ideal for powering devices like mobile phones, laptops, and digital cameras. The compact nature and reusability of lithium-ion batteries allowed them to power the rapid growth of personal electronics, as well as portable tools and equipment. Lithium-ion batteries became the standard in consumer electronics and established a platform for further development in energy storage. As lithium-ion batteries gained prominence, the technology also found its way into electric vehicles. In the early 2000s, companies like Tesla, Nissan, and Chevrolet began developing electric cars powered by lithium-ion batteries, which allowed for longer driving ranges and faster recharging times compared to earlier battery technologies. The increased interest in electric vehicles, combined with environmental concerns about fossil fuels, pushed the development of larger, more efficient lithium-ion batteries and led to the widespread adoption of electric vehicles. In the 21st century, battery technology has continued to evolve in both research and real-world applications. One major trend has been the drive to improve the energy density of batteries as energy demand continues to increase in areas like electric vehicles, renewable energy storage, and portable electronics. Researchers have explored new materials such as lithium iron phosphate, LiFePO4, and nickel-manganese-cobalt (NMC) composites to improve the performance of lithium-ion batteries while reducing costs and enhancing safety. Another important area of development has been fast-charging technology. As the adoption of electric vehicles grows, the ability to quickly charge batteries has become increasingly important. Advances in fast-charging infrastructure, as well as innovations in battery design, are helping to reduce charging times significantly. Technologies such as graphene batteries and solid-state batteries are poised to push the boundaries of how quickly batteries can charge, and they promise to make electric vehicles even more practical for everyday use. Environmental impact of Hyundai's solid-state battery. The global transition to renewable energy and sustainable technologies is accelerating, and the automotive and energy industries are at the forefront of this change. Hyundai, a leader in the automotive sector, has introduced its solid-state EV Dream battery, an innovation that promises to revolutionize electric vehicle technology. Beyond its potential to enhance the performance of electric vehicles, Hyundai's solid-state battery could have significant environmental and economic impacts. These benefits are crucial as the world seeks to mitigate the environmental consequences of fossil fuel consumption and adapt to a more sustainable future. One of the primary drivers behind the development of electric vehicles is the need to reduce greenhouse gas emissions and combat climate change. Solid-state batteries, such as Hyundai's new technology, represent a significant leap forward in the quest for environmentally friendly energy storage solutions. The environmental impact of these batteries can be analyzed in several key areas: efficiency, material sustainability, life cycle emissions, and safety. Efficiency and energy density. One of the standout features of solid-state batteries is their ability to store more energy in a smaller, lighter package compared to traditional lithium-ion batteries. Hyundai's solid-state battery offers a higher energy density, which means that electric vehicles can travel longer distances on a single charge. This increased efficiency addresses one of the primary concerns of consumers, range anxiety, and makes electric vehicles a more practical and attractive alternative to fossil fuel-powered cars. By increasing the energy density, Hyundai's solid-state battery allows electric vehicles to become more efficient, consuming less energy for the same distance traveled. This reduction in energy consumption translates directly to lower overall emissions, especially if the electricity used to charge these vehicles comes from renewable sources such as solar or wind. As electric vehicles powered by solid-state batteries proliferate, the demand for cleaner energy sources will increase, contributing to a reduction in global carbon emissions and helping mitigate climate change, material sustainability, and reduced resource dependence. Traditional lithium-ion batteries rely heavily on rare materials such as cobalt, lithium, and nickel, all of which are associated with significant environmental and social impacts. The mining and processing of these materials have raised concerns about deforestation, habitat destruction, water pollution, and human rights violations, particularly in developing countries where these resources are extracted. Additionally, the limited availability of some of these raw materials has raised questions about the long-term sustainability of lithium-ion battery technology. In contrast, Hyundai's solid-state battery holds the promise of using more abundant and sustainable materials. Solid-state batteries typically use a different set of materials, which can include alternatives to cobalt and nickel, reducing the reliance on these scarce and environmentally harmful resources. This shift could alleviate some of the negative environmental and social consequences of mining for battery materials. The reduced need for rare minerals could also contribute to stabilizing supply chains, making the entire battery manufacturing process more sustainable and less prone to market fluctuations tied to resource scarcity. Moreover, solid-state batteries are generally considered safer to manufacture and use, as they do not rely on flammable liquid electrolytes. This reduces the risk of hazardous leaks or fires, which can occur in traditional lithium-ion batteries when they are damaged or exposed to extreme conditions. This increased safety is not only better for the environment, but also reduces the risk of accidents and damage to ecosystems, life cycle emissions, and end-of-life recycling. The life cycle emissions associated with batteries are an essential consideration when assessing their environmental impact. While the production of solid-state batteries will still involve carbon emissions, the overall emissions during their life cycle are likely to be lower than those of conventional lithium-ion batteries, primarily due to their higher energy density and longer lifespan. With fewer materials needed for the same amount of energy storage, and reduced demand for mining and material processing, the carbon footprint associated with manufacturing solid-state batteries could be significantly reduced. Additionally, the recycling of batteries at the end of their life is another critical environmental consideration. Solid-state batteries are expected to be easier to recycle than traditional lithium-ion batteries due to their simpler and safer chemical structure. As recycling technologies improve, it is possible that the environmental impact of solid-state batteries could be further minimized by reusing materials and reducing waste. As the adoption of solid-state batteries becomes more widespread, advancements in battery recycling could play a significant role in closing the loop on battery production and minimizing the environmental burden associated with waste disposal. The battery of dreams. Beyond the environmental benefits, Hyundai's solid-state battery technology also offers significant economic advantages. These benefits span across the automotive, energy and manufacturing sectors and could contribute to job creation, cost reduction, and the overall growth of green industries. The high energy density of Hyundai's solid-state battery offers the potential for lower operational costs in electric vehicles and energy storage systems. As the efficiency of these batteries improves, electric vehicles powered by solid-state batteries could require fewer charges, translating to reduced energy costs for consumers. For example, an electric vehicle with a solid-state battery may require less frequent charging, reducing the overall electricity consumption per mile traveled. This could lower the cost of operating electric vehicles, making them more affordable in the long term compared to gasoline-powered cars or current EVs with lithium-ion batteries. Moreover, energy storage systems, which are increasingly used in homes, businesses, and utility-scale applications, stand to benefit from the efficiency of solid-state batteries. As renewable energy sources like solar and wind continue to grow, the need for effective energy storage becomes more crucial. Hyundai's solid-state battery could help store excess renewable energy for later use, reducing reliance on fossil fuel-based backup power plants. This shift would lower overall energy costs, making renewable energy a more cost-competitive option in both developed and emerging markets. One benefit will be job creation and economic growth. The development, production, and commercialization of solid-state batteries represent significant economic opportunities. The transition from traditional lithium-ion battery manufacturing to solid-state technology will require new skills, infrastructure, and innovation. This shift could lead to the creation of new jobs in research and development, manufacturing, and recycling. The solid-state battery industry is still in its early stages, and as demand for electric vehicles and renewable energy storage systems grows, there will be an increasing need for a skilled workforce to support this transformation. Moreover, the adoption of solid-state batteries could drive the growth of green industries, particularly in the automotive sector. As electric vehicles become more mainstream, companies that produce solid-state batteries will play a crucial role in the global automotive supply chain. Manufacturers in countries that invest in solid-state battery technology could gain a competitive edge, positioning themselves as leaders in the clean energy transition and contributing to economic growth at both national and international levels. One of the key economic advantages of solid-state batteries is their potential to lower the cost of battery production. While the initial costs of developing and scaling solid-state batteries may be high, advancements in manufacturing techniques and economies of scale could significantly reduce costs over time. As more automakers, energy companies, and battery producers invest in solid-state technology, the price per unit is likely to decrease, making electric vehicles and energy storage systems more affordable for consumers. The scalability of solid-state batteries is another important factor. Unlike traditional batteries, which are limited by their reliance on expensive raw materials, solid-state batteries could be produced in larger quantities at a lower cost. This increased scalability could help meet the growing global demand for electric vehicles and renewable energy storage solutions, driving down costs and ensuring the widespread adoption of clean technologies. Hyundai's solid-state battery technology presents both significant environmental and economic benefits. Environmentally, the increased efficiency, sustainability, and safety of solid-state batteries could reduce the carbon footprint of electric vehicles and energy storage systems, while alleviating the social and environmental costs of mining rare materials. Economically, solid-state batteries offer the potential for reduced operating costs, job creation, and scalability, all of which can drive the growth of green industries and accelerate the transition to a low-carbon economy. The road ahead. While Hyundai's solid-state EV Dream Battery presents an exciting breakthrough, it is important to recognize that challenges remain in the development and widespread adoption of this technology. Solid-state batteries are still in the experimental phase, and scaling up production for use in mass-market vehicles will require significant investments in research, development, and infrastructure. There are also technical hurdles to overcome, such as improving the performance and durability of solid-state batteries in extreme temperatures and ensuring that they can be produced at a competitive price point. Despite these challenges, Hyundai's commitment to advancing solid-state battery technology is a clear indication of the company's ambition to lead the electric vehicle revolution. The potential for solid-state batteries to address key issues like range anxiety, charging times, and safety could give Hyundai a competitive edge in the growing EV market. Moreover, as governments around the world introduce stricter emissions regulations and offer incentives for electric vehicle adoption, the demand for more advanced, efficient, and sustainable battery technologies is only expected to rise. Hyundai's timely investment in solid-state battery technology positions the company to capitalize on this shift and potentially shape the future of transportation. What to expect in the next few years? Among the myriad of technological advancements, Hyundai has positioned itself as a key player in the EV revolution with its development of solid-state battery technology. Solid-state batteries represent a significant leap forward in the field of energy storage, offering substantial improvements in efficiency, safety, and energy density compared to conventional lithium-ion batteries. Solid-state batteries, as a next-generation technology, promise numerous advantages over traditional lithium-ion batteries. The primary difference lies in the use of a solid electrolyte instead of the liquid or gel-based electrolytes found in conventional batteries. Hyundai's solid-state battery, currently in the development phase, is expected to address many of the challenges currently faced by lithium-ion batteries. With their higher energy density, solid-state batteries can potentially store more energy in a smaller and lighter package, which would make electric vehicles not only more efficient, but also more cost-effective. The solid-state technology developed by Hyundai could also significantly reduce the environmental impact of EVs by minimizing the reliance on rare and ethically problematic materials, such as cobalt and nickel, which are often used in lithium-ion battery production. The promise of better performance, faster charging times, and lower environmental costs positions solid-state batteries as a groundbreaking innovation that could change the way electric vehicles are powered. Hyundai has been at the forefront of solid-state battery research and development. In collaboration with leading research institutions and battery manufacturers, Hyundai has made significant strides toward the commercial deployment of solid-state batteries. The company has publicly expressed its goal to produce commercially viable solid-state batteries for electric vehicles by the early 2020s, with some reports suggesting that Hyundai's solid-state batteries could be in mass production by 2025. This ambitious timeline places Hyundai in a competitive position to capitalize on the growing demand for next-generation EV technologies. One of Hyundai's key strategies in the development of solid-state batteries is to create a product that not only offers improved performance, but is also cost-effective for mass production. Currently, One of the barriers to the widespread adoption of solid-state batteries is their high production cost. However, Hyundai is working on scaling production techniques to drive down the cost of manufacturing these batteries. By addressing the challenges of cost and scalability, Hyundai aims to make solid-state batteries a viable option not just for high-end electric vehicles, but also for more affordable, mass-market EVs. This would help further democratize the benefits of solid-state batteries, making them accessible to a wider range of consumers. In addition to technological development, Hyundai's commitment to sustainability is central to its solid-state battery strategy. The company is focused on creating an environmentally responsible product that reduces the carbon footprint of electric vehicles over their entire life cycle. Solid-state batteries, with their potential for higher energy efficiency and longer lifespans, are expected to have a lower environmental impact than traditional batteries, especially when it comes to resource extraction and end-of-life disposal. Hyundai's position on sustainability aligns with its broader corporate goals of achieving carbon neutrality and reducing its environmental footprint, making solid-state batteries an integral part of its long-term vision. Hyundai's EV market position. As of now, the global electric vehicle market is highly competitive, with established automakers and new entrants vying for a share of the rapidly growing sector. Companies like Tesla, Nissan, and Volkswagen have made significant strides in the development and adoption of EVs, while new startups like Rivian and Lucid Motors are bringing fresh competition to the market. Hyundai, however, has managed to carve out a significant position for itself, with a diverse portfolio of electric vehicles and a commitment to sustainable transportation. Hyundai's electric vehicle lineup includes the Kona Electric, the Ioniq 5, and the upcoming Ioniq 6, all of which showcase the company's dedication to producing affordable, efficient, and stylish electric cars. The Ioniq 5, in particular, has garnered significant attention for its cutting-edge design, advanced technology, and long-range capabilities, positioning Hyundai as a strong contender in the global EV market. By leveraging its solid-state battery technology, Hyundai can further differentiate itself from competitors, offering vehicles that boast superior performance and safety features. One of Hyundai's key advantages in the EV market is its ability to combine innovative battery technologies with a comprehensive strategy for EV infrastructure. Hyundai has invested in building a robust charging network, which addresses one of the most significant barriers to EV adoption: charging infrastructure. By creating a seamless ecosystem of electric vehicles, batteries, and charging stations, Hyundai is positioning itself as a leader in the transition to electric mobility. Furthermore, Hyundai's global presence, with manufacturing facilities in key markets such as Europe, North America, and Asia, gives the company the ability to scale its EV production and distribution rapidly. Hyundai's commitment to solid-state battery technology places it in direct competition with other automakers and battery manufacturers that are also investing in this next-generation technology. Tesla, for instance, has partnered with various companies to develop solid-state batteries, and other major automakers, including Toyota and Volkswagen, have been exploring solid-state technology for their future electric vehicles. The competition in the solid-state battery space is intense, and companies that can overcome the technological and manufacturing hurdles will have a significant advantage in the growing EV market. However, Hyundai's early focus on developing solid-state batteries for commercial use gives it a competitive edge. The company's aggressive timeline and strong partnerships with battery research institutions position it as a potential leader in solid-state battery production. If Hyundai can successfully scale its solid-state battery technology and reduce production costs, it will be able to offer a compelling alternative to current lithium-ion battery solutions, gaining a significant market share in both the EV and energy storage markets. The future of solid-state batteries is inextricably linked to the future of electric vehicles. As the demand for EVs continues to rise, particularly in the face of increasing environmental awareness and government mandates on emissions, the need for better, more efficient energy storage solutions will only grow. Solid-state batteries could play a crucial role in addressing the challenges of range anxiety, long charging times, and battery degradation that currently plague electric vehicles. Hyundai's position as a leader in the development of solid-state battery technology could help accelerate the mass adoption of electric vehicles by providing consumers with a safer, more reliable, and more affordable power source. Furthermore, Hyundai's emphasis on sustainability and its vision for carbon neutrality align with the broader goals of the automotive industry and governments worldwide. As regulations become more stringent and incentives for green technologies increase, Hyundai's commitment to developing cutting-edge, environmentally responsible battery technologies positions it as a key player in the global transition to electric mobility. By integrating solid-state batteries into its EV lineup, Hyundai could set new standards for efficiency, performance, and safety, ultimately shaping the future of transportation. Is the world ready for another transition? Write your thoughts below, and thanks for watching.